Good morning and welcome back. We are going to finish our Unit 4 guided notes today, actually. So, last class we were talking about how to write the equation of a line in point slope form and in slope intercept form given specific conditions. Now, the thing that I wanted you all to get really used to was the fact that if you are given a point and a slope, you should automatically start by using the point slope form and then derive slope intercept. If you start with two ordered pairs, meaning you aren't given a slope, then you know what your first step is. Your first step is to find the slope, then use point slope and derive slope intercept. So it's that same kind of pattern that's not going to change. We are going to look at one more problem similar to what we did last class, and then we're going to check out two challenge problems. So what I'd like you to do in the meantime is, good morning, Patrick. What I'd like you to do in the meantime is in the chat, would you please provide to me give me three different ordered pairs. Make sure that there are some negatives in there, okay? Make it fun. I would like three separate ordered pairs and the slope of your choice. I just want you to write that in the chat. You'll see what we're going to do with that in a little bit. Okay, as you're working on that, let's take a look at number 4 before we check out some challenge problems. Okay, so we want to write the equation of a line in point slope and slope intercept form, going through the points -4, 1 and 6, -2. So again, notice that we have two ordered pairs, we don't have a slope, so right off the bat, you should recognize that you need to calculate the slope. What I'll do first is I'm going to label my ordered pairs x1, y1, and then x2, y2. In using the slope formula, we have m is equal to, and I can write the slope formula out again, and I will just because it's good practice and because we haven't seen it since last week, right? Unless you were doing homework over the weekend, which props to you. Very nice. y2 minus y1 over x2 minus x1. Recall that the formula could be reversed. It could be y1 minus y2 over x1 minus x2. So the choice really is yours. y2 is a -2 minus y1, which is 1. Over x2, which is 6, minus x1, which is -4. So I could write 6 minus a -4, or I could write 6 plus 4. I'm just going to write 6 minus a -4, just so that you all recall, oh yeah, that's how we got that value. -2 minus 1 gives us a -3. And 6 minus -4, or 6 plus 4, is 10. So we have just discovered that the slope is a -3 over 10. That doesn't reduce, and we are not going to write that as a decimal. Next, we are going to use point slope form. So I'm going to label it. Remember, you have to be able to identify the type of linear equation. So for instance, on like a test or on some sort of assessment, it may ask, what is the equation of a line in point slope form? You have to know what goes there, okay? And similarly, if they said, write the equation of a line in slope intercept form, you need to know what goes there. So that's why in our notes, we are constantly practicing, this is point slope, this is slope intercept. So we want to make sure that we have a clear understanding of the difference between the two, and especially with point slope, how it's written. Let's take a look. So for point slope form, the general form is y minus y1 is equal to m parentheses x minus x1. We are going to use our first ordered pair. As a reminder, I could have used the second ordered pair, so y minus y2 equals m times x minus x2, since these 2 points belong to the same line. But just for the sake of simplicity, I'm going to stick to using the first ordered pair. So we have y minus y1, which is 1, is equal to, and then m, our slope, good morning, Ethan, no big deal, So m is a -3/10. So we're going to replace m with a -3/10. Parentheses x minus, and then x1 is a -4. Now here, instead of writing x minus a -4, I'm going to immediately clean up the signs. X minus a -4 is the same as x plus 4. When you are writing your point slope form, please make sure that you simplify those signs. So if you have double signs, clean it up. If it's a minus, a negative, clean it up, make it a positive. That's why we made this a plus 4 here. So point slope form is this equation. Point slope form has parentheses. Point parentheses. Point slope parentheses. Okay, I really want to drive that home. As long as your form looks like this, you will earn full credit. So make sure that you're careful with this. Okay, so I'm going to separate this from where we're going. Excuse me. I need to rotate the page just a little bit. So taking point slope form, we are going to then derive slope-intercept form. So check this out. I'm going to start off by writing our equation for point slope form. Y minus 1 is equal to -3/10 times x plus 4. If we wanted to take a step forward, we recognize that the first thing we should do is distribute that -3/10 in order to drop parentheses. We distribute to drop. So we have y minus 1 is equal to -3/10 times x is -3/10 x. -3/10 times 4, think about this again as 4/1, okay? Then you have -3 times 4/10 times 1. Some of you may be thinking to yourselves, wait a second, 10 and 4, those reduce. So we could do a little bit of side work if you'd like. And you know what? Let's just do it. So we have a -3/10 times 4/1. I notice here that both 10 and 4 are divisible by 2. So I'm going to divide a 2 out of both. Dividing a 2 out of both leaves me with -6/5. So I'm going to write that here. If you happen to leave it -12/10, that's fine. Eventually you're going to have to reduce anyways. I just, I try to reduce wherever possible, just to try to make things a little bit simpler. But it's up to you. Next, we want to isolate y, so I'm going to add 1 to both sides. Notice a -1 and a +1, these are opposites, so they cancel each other out. 0 plus y is simply y. Is equal to, we'll bring down the -3/10 x. And then we're going to do some side work again. Here we have -6/5 plus 1. -6/5 plus 1. 1 is a whole number, correct? That's okay, Rachel. Thank you for letting me know. Welcome. 1 is a whole number. We'll place that over 1. As a recall, we know that when we add or subtract fractions, we must have a common denominator. So my LCD in this case is going to be 5. So I'm going to multiply the denominator and the numerator of my second fraction by a 5/5, essentially multiplying by 1. So we have -6/5 plus 5/5. When you take a -6/5 and you add 5/5, that leaves you with -1/5. And there is our equation in slope-intercept form. Let's label it. Slope-intercept form. Good. The great thing about slope-intercept form is that not only do we recognize that the slope is -3/10, I mean, we calculated it, right? So perfect. But second, we can also identify what the y-intercept is. So if I wanted to take it a step further and I wanted to make a note, I would say that the y-intercept is going to be the ordered pair 0, and then notice here my b term is a -1/5. So there is your y-intercept. It's always helpful to think about the values that you are actually getting. If we wanted to calculate the x-intercept, we would actually have to plug in a 0 for y and then solve. And actually, for the sake of making sure that we are all comfortable with that idea, I'm actually going to go ahead and do that. So on a separate sheet of paper, I'm going to write out the slope-intercept form, which is y is equal to negative 3 over 10x minus 1 over 5. By the way, in the meantime, please write down 3 different ordered pairs and a slope. Go ahead and throw that into the chat. So in finding the x-intercept, we recognize that y has to be 0. That's the only way we're going to be on the x-axis. So let's plug in a 0 for y and take a look. 0 is equal to negative 3/10 x minus 1/5. Recall that if we don't want to deal with fractions, we can simply multiply every term in the equation. You can only do this when you have an equation. We can multiply every term in the equation by the LCD. The LCD in this case is 10, right? You take a look at the denominators and you want to find the lowest common multiple. Multiples of 5 are 5, 10, 15, 20. Multiples of 10 are 10, 20, 30. So you see that 10 is our LCD. Take each term and multiply it by 10. And let's take a look at what happens. 10 times 0 is 0. 10 times a negative 3 over 10, well, the 10s will cancel each other out because you're dividing by 10. That leaves you with 1 times a negative 3 times x, which is a negative 3x. For negative 1/5 times 10, notice the 5 goes into the 10. 5 divides into itself once. 5 divides into 10 twice. And that leaves you with negative 1 times 2, which is negative 2. Now, thank you, Patrick. Now, all we have to do is isolate x. So we are going to bring over our 2. Recall from last time that if we wanted to, we could have brought over the negative 3x and made that a positive 3x. It doesn't matter. It's completely up to you. As long as you use the correct opposite operation, then awesome. We have 2 is equal to negative 3x plus 0 because these two are opposites, so they cancel. And that leaves you with the negative 3x. Divide both sides by negative 3, and we find that x is a negative 2/3. So that means our x-intercept is a negative 2/3, comma 0. Not bad. Having said that, I'm going to write that here. X-intercept, negative 2/3, comma 0. As you're looking through your notes, if you're ever wondering how the heck I did this, remember, you can always come back to this video. So I'm going to make a note here, done over live stream video. Okay, so this is done over the live stream video. Perfect. Okay. We are now ready to look at our challenge problems. Before we actually do this, I want to make sure that we're all on the same page. So, in the chat, would you please tell me how you know that 2 lines are parallel to one another? And then, how do you know that 2 lines are perpendicular to one another? So go ahead and share that in the chat. Excellent. So we have some answers coming in. When you consider parallel lines, I'm trying to find my other pen here, we recognize that they will never touch. So Claire, you had mentioned that the lines will never touch. They're parallel. That's true. But more so, Patrick, Ryan, Dakila, you all mentioned that you know that 2 lines are parallel if they actually have the same slope. I mean, beyond having the same slope, they should not have the same y-intercept. If they have the same slope and the same y-intercept, then they're the same line, right? But that's silly. So 2 lines are parallel if they essentially have the exact same slope. Beautiful. Excellent. Very nice, Doc. Now, in considering 2 lines that are perpendicular, so for instance, let's say you had this line, and then you had another one that crosses it exactly at a 90-degree angle, well, that indicates that they are perpendicular. But in terms of their equations, to know whether or not 2 lines are perpendicular is if their slopes are opposite reciprocals. So very nice, all of you. That was fantastic. They will have opposite reciprocal slopes. Johanna, welcome. So for instance, if the slope of this line that you're looking at is negative 2/3, right? Because it's a negative slope, then the line that intersects it will have positive 3/2 slope, right? So it's the negative, or excuse me, the opposite reciprocal. All right? Keeping that in mind, let's take a look at our challenge problem. No worries, Johanna. I'm just glad you're here. Okay, we want to write the equation of a line in slope-intercept form parallel to, and I'm going to write the equation that Patrick gave us, so you could blame him if you're not happy. Just kidding. So y is equal to 1/3 x minus 7, okay? But going through the point, and we're going to choose -4, 1. Excellent, Patrick. Those were awesome suggestions. So we're going to write the equation of a line in slope-intercept form of the line parallel to y equals 1/3 x minus 7, but going through the point -4, 1. Okay, this is actually pretty interesting because you're probably thinking, whoa, what do we do? How do I do this? Well, breathe first, and then consider what it's asking you to do. Write an equation of a line that's parallel to this one. So the line is parallel, which means it has to have the exact same slope. If the two lines are parallel, the one we are going to come up with and the one we were given, then that means the slope has to be 1/3. It has to be identical. Now check this out. We have taken the slope from our equation, so we're done with this. But we're also told that the line we have to come up with goes through the point -4, 1. Okay, that's hugely important to consider. This line was provided to us, but we need another line that's parallel, but it goes through this point instead. So let's go ahead and use point slope. We use point slope because we're given a point and a slope. Think about that logically. Consider the information you're given. So we've got y minus y1 is equal to m times x minus x1. Our ordered pair is a -4, 1. So we're going to call this our x1, y1. Now all we have to do at this point is substitute our values. What I'd like you to do is I would like you to substitute the values, tell me the equation in point-slope form, and then continue through the process to find slope-intercept form. Let's do this in a couple minutes starting now. First things first, we have a slope, we have a point. So we're going to use these three pieces of information in our point-slope form. This line, the only reason we use this line was to pull its slope, because we know that the one we are going to come up with is parallel to this one. So we don't worry about the y-intercept. All we worry about is taking that slope and saying, oh, our new line has the exact same slope. So we use y minus y1. y1 in this case is 1, is equal to m, which is 1/3, times x minus x1, which is -4. So x minus a -4 is the same as x plus 4. So when I asked you what was your point slope form for the equation of a line, and you said y minus 1 is equal to 1/3 times x plus 4, that was excellent. That's exactly correct. That's what you wanted for your point slope. But that's not exactly what we're being asked right now. We're being asked to find the equation of a line in slope-intercept form. So I'm simply going to rewrite this equation, and I'm going to move forward. I'm going to move forward by distributing the 1/3. So I have y minus 1 is equal to 1/3 times x, which is 1/3 x, 1/3 times 4, which is 4/3. You can always do work on the side if that trips you up. Or think of it as 1/3 times 4/1. So it's 1 times 4/3 times 1, 4/3. Next, I must isolate my y, so I'm going to add 1 to both sides. That leaves me with y, those cancel, is equal to 1/3 x, and then we're going to add 4/3 plus 1. So if you wanted to, you could do a little bit of side work here. So we can say 4/3 plus 1/1. We know we're adding fractions, so we need an LCD, which is 3. So that becomes 4/3 plus 3/3, which gives us 7/3. So our final answer is y is equal to 1/3 x plus 7/3. Excellent job, all of you. Excellent work on your effort. So let's label this slope-intercept form. And that is the solution that we were looking for. Okay? If you have any questions, as always, please don't hesitate to throw those into the chat. Okay? Don't hesitate whatsoever. All right, last page of our notes. The extra challenge problem. So, we are going to write the equation of a line in point-slope form and slope-intercept form given the following info. The first thing we're told is that line A is perpendicular to line B. Okay, that's the first thing we're told. So if it helps, I'm going to put like a little bullet here. The second thing we're told is that line A goes through the points 3, -5, and -2, 4. Line A goes through the points 3, -5, and -2, 4. Line B goes through the point -1, -3. Now, this one is definitely tricky, but I still want you to give this a shot. I want you to think about what's happening here. I want you to break this down piece by piece. So here's my advice. For the first bullet, write down what that means. Write down what it means for line A to be perpendicular to line B. That's the first thing I'd like you to do. Then, deal with the information from our second bullet, which is that line A goes through the points 3, -5, and -2, 4. Think about what we've had to do this entire time when we're given two ordered pairs. And then finally, using both of these pieces of information, apply the third bullet, which is that line B goes through -1, -3. I'm going to give you 5 minutes to play around with this. Good luck. Okay, let's do this. The first thing we know is that line A is perpendicular to line B. So essentially, the slopes are going to be opposite reciprocals. That's the first thing we have to know, that the slopes of line A and B are going to be opposite reciprocals of each other. That means I need to figure out what is the slope of line A. So we're going to start by identifying the slope of line A. We have two ordered pairs that line A goes through. So let's calculate the slope. M is equal to, and we're going to call this x1, y1, x2, y2. Using this information, we can fill in our slope formula. So y2, which is 4, minus y1, which is -5, over x2, which is -2, minus x1, which is 3. So y2 minus y1 over x2 minus x1. Simplifying, we get 4 minus -5, which is a +9. And then we have -2 minus 3, which is a -5. So the slope of line A is -9 over 5. Now, we know that line A is perpendicular to line B. So that means the slope of line B must be the opposite reciprocal of this slope. So the slope of line B must be the opposite reciprocal, meaning the slope of line B is positive 5/9. So that takes care of the first 2 points that we're given, right? Next, we're told that line B goes through the point -1, -3. Our role right now is to find the equation of line B. So let's do that. We want the equation of line B. We know that the slope is 5/9, and we know that it goes through the point -1, -3. So we're going to call that x1, y1. Because I have a slope and a point, I must use point-slope form. So we're going to start there. Because I have a point and a slope, we use point-slope form. Y minus y1, so y minus a -3 is the same as y plus 3, is equal to m, which is 5/9, times x minus x1, but x1 is a -1. So x minus a -1 is the same as x plus 1. And that is point-slope form for line B. So this is good. I'm actually going to put a box around this to indicate that we found point-slope form for the equation of line B. Next, I'm going to rewrite my point-slope form, and I'm going to distribute so that I can derive slope-intercept. So we distribute the 5/9, that gives us y plus 3 is equal to 5/9 times x, which is 5/9 x, and then 5/9 times 1, which is just a positive 5/9, right? 1 is our identity. Next, I'm going to subtract 3 because I need to isolate y. Remember, the goal is y equals mx plus b, slope-intercept form. So we bring down the 5/9 x, and then I'm going to do some side work because we have 5/9 minus 3. So we have 5/9 minus 3/1. Notice when we add or subtract fractions, we cannot reduce across the numerator and denominator. If you are in the habit of reducing this 3 and this 9 across a minus, shake yourself and tell yourself never do that again. Okay? Seriously, like, get that out of your system. No more. When you add or subtract fractions, we're subtracting them, you need to have a common denominator. You cannot just cancel across subtraction. You can only reduce numerator for denominator across multiplication or in a single fraction. So, having said that, my LCD in this case is 9. So I need to multiply both the numerator and denominator by 9. This gives me 5/9 minus 27/9. When you take 5/9 minus 27/9, that leaves you with a -22/9. So I go ahead and I write minus 22/9. I'm going to circle this equation, and that is my slope-intercept form. And that is how this problem is done. There was a lot going on in this particular problem, but it was all manageable. We were able to take this one step at a time and think about all the clues that we were given. You knew line A was perpendicular to line B, so you know that their slopes are opposite reciprocals. And then you think, wait, what is the slope for line A? And then you notice, oh, I have 2 points. So I can calculate the slope for line A, which you find is -9/5. After you found the slope for line A, you said, oh, wait a second, they're perpendicular. So that must mean the slope of line B is 5/9. And then you say, okay, well, if I know the slope and bullet 3 tells me the point that line B goes through, then bam, I have enough information to find the point slope and the slope-intercept form for the equation of line B. All right, I hope that made sense. I hope that it was super clear to you. That concludes Unit 4. We're officially done. I did mention that was a challenge problem, right? There was a lot going on in there, but I wanted you to see how you can kind of go through each of these emotions, okay, to make sense of this. Wonderful job today. That was excellent work. I hope it wasn't too confusing, but that finishes Unit 4, so make sure you're practicing, okay? Have a wonderful rest of your day, and I will see you tomorrow for our second day of week 8. Bye, everyone.